So far we have looked at discrete distributions like Poisson binomial. Let us now look at the continuous distribution, and the most important one out of that is normal distribution. Normal distribution is also called bell shaped curve, Gaussian curve and so on, and generally we assume any data behaves like a normally distributed. That means if I take 10 or 20 students in a class and measure their heights, generally it will fall in a normal distribution. That means there will be an average, there will be some students who will have less height than the average, some students will have greater than the average, and the proportion will be almost same. Okay, there are certain terminologies which you need to learn, and they are quite simple. You must have studied a long time back also. They are called mean, median, mode. What is a mean? Suppose I have a set of data and I want to find the mean of this data set. Mean is nothing but taking the average. So it is quite simple. So we add all these and divide, and then we get the mean. Now what is the median of this? Suppose we arrange the data set in this fashion. The middle point is called the median. So if you have even number of data, so the middle point will be average of these two, whereas if you have odd set of data, the middle point will be the center data point. So in this particular case we have 8 data sets, and the median will be average of 12 and 13. Okay. Now what is mode? Mode is nothing but the value which comes more often. Okay. For example, it is centered around that value. If you look at this data set 8, 11, 12, 12, 13, 14, 16, 18, okay. So we find 12 as more common, or the distribution is centered around this. So the mode is 12 in this case. So this particular data set we have a mean of 13, median of 12.5 and mode as 12. And generally for a normal distribution the mean, median, mode are the same. That is why normal distribution is called a uniformly distributed data set, and it will look like a bell shaped well distributed data set. Okay. Then there is something called mid hinge. Suppose you have a quartile 1. What is quartile 1? So you have a large data set. Assume that you can divide this data set into 4 quarters or quartiles. Okay. So this is called the first quartile, and this is called the third quartile. Okay. So we have divided it into 4 data sets. So you have the Q1 here. So 25% of the data will be smaller than this Q1, 75% of the data will be larger than this Q1. Okay. So you have a Q2, that is the quartile 2. So 50% of the data will be smaller than this, and 50% of the data will be larger than this. Then we have the third quartile Q3, 75% of the data will be below this Q3, and 25% will be above this. Okay. So if it is very uniformly distributed, you will have each of these quarters same, but if it is not uniformly distributed, you will have some variations between Q1 and Q3 and so on actually. So mid hinge is nothing but the middle point, like, so that is Q1 plus Q3 by 2. In this particular case we have here, okay, and we have here, take an average, it comes to 501.45. So generally the quartiles are very useful to determine whether the data set is uniformly distributed or is it skewed in one particular range, whether Q1 is not same as Q3, maybe it is skewed, and so on actually. That is the advantage of looking at the quartiles in data set. Range is nothing but the largest point minus the smallest point. So if you have a large data set like this, so the range of the data is 509 to 491. So if I am measuring the fermentation yield between 50 and 20 degrees, I would say 50 is one end, 20 is another end, the range is 30 degrees. So if I am measuring the growth of an organism between pH 3 and 8, so the range will be 5. So this is very obvious, and we have been using that. Then there is also interquartile range, that is nothing but Q3 minus Q1. Okay, so you know Q3 you know q1, so you find the difference, that is called the interquartile range. Okay. Now let us look at the variability of the data. The mean is okay, median is okay, mode is okay, but then we would like to know how these data set varies with respect to this average. Okay, that is a very important point, because that gives you an idea about the spread of the data. Okay. Suppose I am measuring the height of the student in my class, I am getting an average of 5.5. Do all the students have their height very close to 5.5, or is there a large difference from this average of 5.5? Do we have students with 6, do we have students with 5? So that will give you a very large spread, and that is going to give you a very large standard deviation. Whereas if the height of the students are very close to 5.5, 5.6 or 5.4 or 5.3, the variations are going to be very small, then the standard deviation of this data set is also going to be very small. So how do you calculate that? You must have studied long time back. So if x bar is the average of the data, suppose I have 500.4, 502.8, 499.8, 499.1, 503.1, 498.1 as the data set, I take an average which is this. So x bar minus x whole square, that is I take the difference with respect to the average, square it up, then I add all of them. This is called sum of squares. Okay. This is called sum of squares, and this is also called variance. Okay. So the sample sum of squares divided by n minus 1, n is the number of data points, so sum of squares divided by n minus 1 is called the sample variance. So I take the difference between the x bar, which is the mean, and the data point, square it up, I add up, there I get this something called sum of squares. So if I divide this sum of squares by n minus 1, we get something called sample variance. It is denoted by a square. Why is this called sample? Because you have taken a small set of data. So the sample standard deviation, you take a square root of that, that gives you the sample standard deviation. Now this variance and the standard deviation gives you an indication of the spread of the data, that means how much the data is spread. So if the variance is very large or the standard deviation is very large, we can tell the data spread with respect to the mean or the average is also very large. If the standard deviation is very small, then we can say the spread of the data with respect to the mean is also very small. So that is the advantage of this, and variance is very important. As I mentioned in my first class, that variation is part of any data, and so understanding this variation and the reasons for this variation is very important in the area of statistics. Okay. And identifying what are the causes, what are the reasons for this particular variance is very important. Okay. So this standard deviation or the variance of the sample is the way, this is how you calculate x bar minus x square, that is given as sum of squares, then divided by n minus 1. Okay. Now in the previous class I mentioned about population and sample. Population is something very big, you cannot even comprehend. It is a very large data point, set of data. Okay. So it is like telling the height, the average height of an Indian is 5.5 feet. Okay. That means it involves billions of Indians. Okay. That is a population. Whereas if I take about 10 people who are walking down the street and take their average height, then that is called a sample. That will be represented generally as x bar, and whereas when I look at the average height of an Indian, I will call that as mu. Similarly, generally we say sigma as the population variance and S as the sample variance. So analogous to S square, we also have sigma square, where we say sum of squares divided by n. As you might have noticed, instead of n minus 1 which we have it here we are just having n, because in population the number of data points are huge, that does not make much difference whether we take n or n minus 1. Okay. So the population standard deviation of course is square root of this. Now we can calculate all these mean, mode, median, standard deviation from Excel also, right. There are some commands like average. So suppose if I have a large set of data, I use this function to calculate average. If I have a large set of data, I can use this function median to calculate the median. If I have a large set of data, I can use this function called mode to calculate the mode or the central tendency. If I have a large set of data, I can use this command called standard deviation to calculate the standard deviation of the data set. For example, let us just look at Excel. So suppose I assume that I have some data points, okay, I am just giving randomly some data points. So I need to calculate the average. So I put average, average. I put all these points here and I get an average of this, okay, this is the average. So easy. If I want to calculate the standard deviation of this sample set, I just write SDEV and then I mark all this, I get the standard deviation, okay. Suppose I want to calculate the median, okay, I just say median. Median is nothing but the midpoint, right, okay. So 13 is the median, okay. So as you can see 12, 12, 13, 13, 14, 15, so the middle point is median. Now mode will be is a central tendency, okay. So we have mode as 12 here, okay. So we have average or the mean here, we have the median here, we have the mode here, we have the standard deviation. So these are quite simple commands which Excel also has it, and we can calculate all these in Excel also. It is very simple, okay. Now let us look at normal distribution. It is the most important in statistics. As I said, we assume for many systems behave in a normal fashion, but of course there are some tests which we have to perform to find out whether it's the data set follows a normal distribution. So if it does not follow, then we have to be very careful to use some of the statistical analysis and statistical tests. We need to remember that. So normal distribution is very uniform, it is like a bell shaped. What the area under the left hand side is exactly equal to the area under the right hand side. The equation is given like this: fx is equal to, that is probability of this function x is equal to 1 by square root 1 by sigma square root of 2 pi e power minus x minus mu whole square by 2 sigma square. So mu is the mean or the average and sigma is the standard deviation. So normal distribution is symmetric. So we know that in a normal distribution the mean, mode and median will all be equal to mu, especially in a normal distribution mean is equal to mu, mode is equal to median equal to mu, okay. So there is something called standardized normal distribution. So the normal distribution we can convert into standardized normal distribution, okay, that is generally represented as z. How do you convert that? So we take z is equal to x minus mu by sigma, okay, mu is the mean of the population, sigma is the standard deviation. So when we do that, okay, so what will happen? The mean will become 0, that means you are sort of transforming it and you are shifting it so that the mean becomes 0, okay, and the area under the curve becomes 1 and sigma becomes 1. So mean becomes 0, that means you have shifted your curve and then you have adjusted your curve so that the standard deviation is 1 and the area under the curve is exactly 1. So this is very useful because instead of handling problems where the averages and standard deviations are differing wide apart, when we use the standardized normal distribution, we will know that the mean is 0 and the area under the curve is always 1. So that is very useful to use. So we can convert most of the problems into standardized normal distribution, and there are tables which talk about area under the curve for different values of x actually, okay. So, we will do some problems under that. So, this is a standardized normal distribution where we have the mean as 0, area under the curve is 1 and sigma is 1. So, we have mu plus sigma, mu minus sigma, mu plus 2 sigma, mu minus 2 sigma, mu plus 3 sigma, minus 3 sigma. So, corresponding to that z, if you see, it will become 1 sigma will become 1, 2 sigma will become plus 2, 3 sigma will become plus 3. So, minus 1 sigma will become minus 1, minus 2 sigma will become minus 2, minus 3 sigma will become minus 3. Okay. So, all you have to do is here you substitute there, mu is equal to 0, x is equal to minus 3 sigma. So, z will become minus 3. Okay. Now, as I said, this is area under this curve, it is equated to 1 in a standardized normal distribution. So, if you have plus or minus 1 sigma, this particular area is 68.3% of the total area. That means it will be 0.683, plus or minus 1 sigma is 0.683, plus or minus 2 sigma it is 95.4%, that means approximately 0.95. So, this area spanning the plus or minus 2 of z will be 0.954. Similarly, plus or minus 3 sigma will span 99.7% of this area. Okay. So, plus or minus 1 sigma will span 68.3% of the area, or it will have a value of 0.683, or plus or minus 2 sigma will have a value of 95.4 or 0.954 area, plus or minus 3 sigma will be 0.997, and so on. We can have plus or minus 4 sigma, 5, 6 and so on, actually, because this is an exponentially decaying. So, as you go along we will add little bit of the area, because the area as you go along becomes smaller and smaller, but still it will try to span as much of the area as possible. Okay. So, when you say plus or minus 1 sigma, this area is 68.3. Okay. That means the remaining area, this plus this, is going to be approximately 32%. Similarly, plus or minus 2 sigma, this area is 95%, say. When you say 95%, the remaining area is 5%. That means this side will be 2.5% and this side will be 2.5%, assuming it to be symmetric. Now, similarly, plus or minus 3 sigma, if we call this as 99%, the remaining outside will be totally 1%. That means this side will be 0.5%, this side will be 0.5%. Okay. So, plus or minus 2 sigma will be 0.95 area, the outside will be 0.5. So, this side will be 0.25, other side will be 0.25. Similarly, plus or minus 3 sigma will be approximately 99%. So, outside area will be 1%, that means this side is 0.5%, the other side is 0.5%, or 0.005 and 0.005. Okay. So, that is the advantage of converting the data set of a normal distribution into standardized normal distribution. So, what you do is, if I know the mu and if I know the sigma, all I do is z is equal to x minus mu by sigma, because you are shifting the curve so that x becomes 0, and the area under the curve becomes 1 and sigma becomes 1. So, when I say plus or minus 1 sigma, z is equal to 1 minus 1. When I say plus or minus 2 sigma, z will be plus 2 and minus 2. When I say plus or minus 3 sigma, z will be plus 3 and minus 3. Now, these numbers are also very important. When you say plus or minus 1 sigma, area is 68.3%, plus or minus 2 sigma 95%, plus or minus 3 sigma 99%. These numbers will become very important, because later on we are going to, you will keep on looking at this 95%, 99%. So, when you say 95%, you are talking in terms of plus or minus 2 sigma. So, when you are talking 99%, you are talking in terms of plus or minus 3 sigma. Generally, in statistics, most of the significant analysis is done around 95%, that is 2 plus or minus 2 sigma, or 99%, that means plus or minus 3 sigma. So, we are looking at data spreading around the average with plus or minus 2 sigma, which is 95%, or plus or minus 3 sigma, which is 99%. So, many in the future we are going to use these two numbers 95 and 99, and now you understand what it means. 95% means it is spanning a plus or minus 2 sigma area, 99% means it is spanning a plus or minus 3 sigma area. Okay. Now Z can also be calculated with the Excel. Okay. There is a command called normdist Z, okay, normdist Z, and as I said the area under the curve is 1. Okay. So if I want to calculate what is this area, okay, and what is this area, okay. So at this place, suppose I give a value of Z here and I want to calculate this area, okay, and I want to calculate this area. So I can use this particular command 1 minus normdist Z, okay, normdist is this particular area. So if you want to know what this area is, I can just say 1 minus normdist, okay. So when I put Z is equal to 0 in normdist, it will give me as 0.5, that is this area, correct, because this whole total area is 1. So we can say this area is 0.5. So when Z is equal to 1 here, that means here, so this area, okay, is equal to 0.841. So when Z is equal to 2, so this area is 0.977. So the remaining area will be 1 minus 0.977, that means 0.023, and if I put here Z is equal to 3, it will give me as 0.998. So if I want to calculate remaining area, I put 1 minus normdist, okay. So let me do it for you here, okay. I just say normdist, oh sorry, normdist it is, yeah, that is 0.5, okay. So when I put a normdist is equal to 1, that is 0.841, that means what I am saying is when I put it here, okay, this side of the area is 0.84, okay. When I put it here, Z is equal to 2, this area is 0.977, okay. So 0.84, so when I put it as a 2, then 97. So the remaining whatever is on the right hand side, if I want to calculate, I put 1 minus this, that is equal to 0.2275, okay. That is whatever on the right hand side is given by 0.02275. Similarly, when I put Z is equal to 3, it gives me 0.998, that is this area. So if you want to know what is this area on the right hand side, I will say 1 minus this. So using Excel also we can do, and the command here is normsdist, and you can also use the graph pad also to do the same thing actually, you know, but the graph pad gives it to you in another form. When you put Z, it gives you the area on both sides, outside area actually, okay. So whereas Excel gives this area, GraphPad gives you the area outside, both sides, that is called two tail, okay, the two tailed. So when I give Z is equal to 2, sorry, Z is equal to 1, it gives me this area. When I give Z is equal to 1, it gives me this area, and so on actually. So here it is giving these two. So suppose if I want to know only one side of it, I just divide by 2 to get the area on only one side of it, understand. Okay. So we can use the graph pad also to calculate. As you can see, it tells you how to calculate different parameters here, statistical distributed interpretation, okay, to calculate. So we can say here we have okay, so we can give a number. So suppose I give a number as 0, so it is giving it as a p value, that is whatever is outside. So if I give a number as z is equal to 1, okay, is giving us 0.3173, okay, 0.3173, okay. So that is the outside area, and so on actually. So when I give z is equal to 2, okay, so it is giving 0.0455, that means it is giving this area. 0.0445 is almost that is this one, okay. It is giving it as 0.0455, okay, that is approximately 0.5, okay, and so on actually, okay. Actually there is a mistake here, so this should be 1 here, okay. Okay, so we can use either the norms dist command in Excel, or we can use GraphPad to calculate z, and you can use numerically using a calculator also from this formula z is equal to x minus mu by sigma, okay. This is very useful because when we convert any data into a standardized normal distribution, we are shifting it so that the mean comes out to be 0 and the area under the curve comes out to be 1. So we will do lot of problems as we go along using this type of commands, okay. So for example, if I want to calculate at 2.5 sigma, what is z? So it is very simple. So all I do is I will put 2.5 sigma, mu will become 0, so z will become 2.5. Now for z is equal to 2.5, what is the area? I can use one of these, I can use norm dist to calculate this area and then subtract from 1 to get this area. So how do I do that? So I will put go to Excel, I will do 1 minus norms dist will give you 0.00621, okay, that is this area is 0.00621, whereas if you want the whole area, and that is what norms dist give actually, okay. So that is the advantage of converting a normal distribution into standardized normal distribution, and we are going to do many problems using this particular command. So if you look at this table, this is called a single tail z table, okay. It is single tail because we are looking at only this, okay. So when z is equal to 0, that means if it is here, this area this area is 0.5, that is what this gives, okay. When z is equal to okay, so when z is equal to 0 here, so when z is equal to 1 here, okay, this area will be 0.1587. So if you are looking at two tails, but that means if you are looking at both the sides, all you have to do is multiply 0.1587 with 2. So you will get about 0.316, correct. So in fact that is what this is, 0.316, that is both the sides area or double tail, whereas this table gives you the single tail here, okay. And similarly if you are looking at for z is equal to 2, what is the area on this side? It will be going down 0.0228. If I want a two tail, then I multiply 0.0228 with 2, that comes to around 0.0456, and that is what we have here. The GraphPad gives 0.0456 because GraphPad gives you on both the sides, okay. It is called the two tail. So I am introducing one more terminology that is called single tail and two tail. Now one side of it single tail, if you are looking at a situation where you have both sides of it, that is called two tail. So we will be using this terminology quite often. So GraphPad gives you area for both the sides, so if I want to calculate only one side, I divide by 2, or if I use this table gives you area outside on only one side, so if I want to calculate both sides, then I multiply by 2. So for 2 I am getting 0.228, for 3 it is 0.0013, so if I want a two tail it will become 0.0026, that is what GraphPad gives, 0.0026. So, we can use different approaches, we can use this table, we can use the norm dist which gives in a different way, and you need to convert 1 minus and then if you want 2 tail you multiply by 2, or we can use this graph pad calculator which anyway straight away gives both the sides. So many different approaches by which one could calculate the area under the curve, either internally area or the 1 minus area for a given z, and this is called a standardized normal distribution. So, in the next class we will look at some problems related to the standardized normal distribution and how useful it is, you will see when you start doing problems in this case. Thank you very much for your time.